Assalamualaikum and hello everyone. So we are from Group 6 and today we're gonna present our video presentation, and the title is the determination of vitamin C. So without further ado, let's go. So this is our group members, which is consists of 3 people, which is starting from me, and my name is Muhammad Farhan bin Muhammad Jasmine, and my student ID is 2022-83-9514, and the second members is Muhammad Daniel Hafiz bin Amran. The student ID is 2022-623738, and the last members is Khairil Danish Irfan bin Hairi Azam, and the student ID is 2022-625706. So before we jump into our main discussion, let me introduce you guys about our background of experiment for today. The ionometric determination of vitamin C by the back titration involve the oxidation reduction reaction between the iodine and ascorbic acid, which is the ascorbic acids contain a lot of vitamin C. This method leverage the principle that ascorbic acid, a strong reducing agent, can quantitatively reduce iodine to iodide. In this procedure, an excess of iodine is added to the vitamin C solution, and the unreacted iodine is then titrated with the standard solution of sodium thiosulfate. The endpoint is typically determined using a starch indicator, which is from a blue complex iodine. This method is highly accurate and widely used due to the simplicity and the effectiveness in quantifying the vitamin C content in various samples. Research by Patel highlight the utility of this method in nutritional and pharmaceutical analysis, noting its precision and reliability. So now we're going to go through step one by one, which is how we can determine the presence of vitamin C in the ascorbic acid using the ionometric back titration. So now we're going to see the objective of our experiment, which is to determine the presence of vitamin C in ascorbic acid by using a back titration method, which is from this experiment we can determine the specific number or the specific percent of the vitamin C in the ascorbic acid.
We have 3 theory why we use back titration for determination of vitamin C. The first one is improved accuracy for weak acid. Vitamin C, or known as ascorbic acid, is a weak acid. So we cannot use direct titration because due to the slow reaction with the titrant. Vitamin C also react rapidly with iodine, but the iodine is not stable and can evaporate. And so the next theory is addressing low solubility. Vitamin C has low solubility, so instead of we use direct titration method, we use back titration because it's allowed for complete reaction by using excess reaction. And the last theory is overcoming interferences. Presence of other substance in samples might interfere with direct titration. So using excess reagent that selectively react with vitamin C help isolate the measurement. So the next is methodology. Method that we use for this determination is back titration. So what is the back titration? Back titration is a method used to determine the concentration of an analyte by reacting it with an excess of known reagent and then titrating the remaining unreacted reagent. So back titration analysis method, we list 8 analysis. Number 1 is prepare materials needed, basically like we prepare apparatus and chemical that we want to use in this experiment. Number 2 is preparation of sample, as this step like dissolve solid sample in a small amount of distilled water. And number 3, add excess reagent. Number 4 is a reaction to allow reaction to complete. Number 5 is titrate excess reagent. In this step we also use indicator. Number 6, perform the titration. Number 7 is record the data that we collect. And the last one is calculate analyte content, like we determine the amount of sample.
So now we're gonna look the apparatus and chemical that we will use in this experiment, which is starting from the apparatus. The apparatus consists of a few items that we list out, which is starting from the burette. Typically, we will use the 50 ml of burette for the titration. The next item is the pipette, which is consists of 10 ml and 25 ml pipette for accurate measurement of solution. The third item is the conical flask, which is we can use either 250 ml or 500 ml to carry out of the titration. The next item is the volumetric flask, which is we can use 100 ml, 250 ml and 500 ml for preparing the standard solution. And the next item is the beaker, which is we will use 100 ml and 250 ml for preparing and transferring solution. And the next item is the glass rod for stirring the solution. And the next item is the funnel for transferring liquid without spillage. And the next item is the wash bubble, which is containing the distilled water for rising. And the next item is the dropper for adding the small amount of indicator or starch solution. And the second last item is the analytical balance for weighing ascorbic acid and potassium iodide accurately. And the last item will be the measuring cylinder for measuring the accurately of the chemical. So now we're gonna see the chemical that we will use in this experiment, which is starting from the potassium iodide, which is Ki2,3, which is the primary standard for preparing the standard iodine solution. The second chemical is the potassium iodide, which is Ki. The function is to react with the KiO3 to produce iodine. And the second chemical is the sulfuric acid, which is H2SO4. Is used to the acidify the solution. The next chemical is the starch solution, which is for the indicator to detect the endpoint of the titration. And the second last chemical is the distilled water, which is for the preparing solution and rising. And the last one is the vitamin C sample. And in this experiment, we will use the ascorbic acid for the sample.
We proceed to setup procedure. In this procedure, there have 7 steps. Step 1 is preparation of sample. In this experiment, we use iodine. So we dissolve iodine in a small amount of distilled water. And step 2 is titrate with sodium thiosulfate. We pipette known amount into a flask, then titrate iodine with a sodium thiosulfate until the iodine color fades to pale yellow. Step 3 is preparation of vitamin C. We crush the vitamin C and dissolve it. Next step is add excess iodine solution. We pipette a known amount of iodine into a vitamin C solution. Step 5 is reaction period. This period usually take about a few minutes. Step 6, do the titration. We titrate the vitamin C with iodine and add 1 or 2 drop starch indicator, then shake until the color change to blue-black, and the last step is determine amount of vitamin C. This is procedure. The first one is preparation of iodine solution. As we can see in this video, step 1 is weigh the mass of iodine molecule needed to prepare a 100 ml 0.05 molar solution. Step 2 is dissolve iodine molecule into a small amount of distilled water. Then step 3, we transfer the iodine that have dissolved in a 100 ml volumetric flask. Add more water to remaining iodine and transfer again into the volumetric flask. Dilute to mark. Second one is standardization of iodine solution. Step 4, to standardize the solution, we pipette 10 ml sodium thiosulfate solution into a 250 ml conical flask. Step 5, dilute the roughly 100 ml of distilled water. And step 6 is titrate with iodine solution with a drop of starch indicator. The color will change from colorless to blue. And the last one is determination of ascorbic acid in vitamin C tablet. Step 7 is obtain a commercial vitamin C tablet and record the amount of active ingredients state on the label. Step 8, crunch the tablet in 25 ml 1 molar sulfuric acid and dilute to 100 ml in a volumetric flask. Next step is pipette 25 ml of the vitamin C solution into 250 ml conical flask, and the last step is add a drop of starch indicator and titrate with iodine solution.
Now we will analyze the result. Now we will talk about the example of our result. This is the endpoint for our titration. The color will change from colorless to a light blue. For the result data, our weight of vitamin C tablet is 0.1871 gram, and then the amount of titrate of vitamin C that we use is 14.83 milliliter, and then the standardization of the iodine solution is 38.85 milliliter. Now we will go on to the calculation of the concentration of ascorbic acid in the vitamin C tablet. First, we have to determine the molarity of iodine solution through the standardization of iodine solution. From that, we got 0.051 molarity of iodine solution. From the molarity, we need to find the number of mole of iodine solution, which is 0.001981 mole of iodine solution. Next, we have to calculate the number of mole of sodium thiosulfide, that we got 0.001 mole of sodium thiosulfide. From the number of mole, we have to find the mole of iodine solution, that we got is 0.0005 mole of iodine solution. Next, we have to find the excess of iodine solution by subtracting the 0.001 of iodine solution from the molarity with 0.0005 of the number of mole from the sodium thiosulfide. Next, we have to find the number of mole of the ascorbic acid, that we got is 0.00005. Through that, we can find the mass of ascorbic acid using the formula of mass equal to mole times molar mass of ascorbic acid. From that, we got 0.79 gram of ascorbic acid. With that, we can calculate the weight over weight of the ascorbic acid by dividing it with mass of the tablet, that we got is 42.25%. Lastly, we will go on to the result interpretation. What the manufacturer claimed that there is 42.9% of vitamin C in the tablet. From our titration and calculation, we can determine that what the manufacturer said is true. Since from our calculation, we got 42.25%.
Conclusion: to determine the vitamin C content in a sample, a back titration method is employed. This involves adding excess of iodine to the vitamin C solution, where vitamin C reduces the iodine. The leftover iodine is then titrated with a standard sodium thiosulfate solution to quantify the remaining iodine. The apparatus required includes a burette, pipette, conical flask, and beaker, while the chemical needed are the vitamin C tablet, and we dissolve to make it a solution, iodine solution, and sodium thiosulfate solution. The procedure involved is reacting the sample with iodine, then titrating the unreacted iodine with sodium thiosulfate. By analyzing the result of the titration, the vitamin C content in the sample can be accurately determined.